Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 8 video on the topic of determination of density of solids, which is from the chapter physical quantities and measurements, where I will solve 5 multiple choice questions. This is set 1. The key concepts and formulas about how to determine the density of solids was discussed in part 7 video. If you if you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 8 video, where I will solve 5 numerical problems on the topic of determination of density of solids. Okay, so the first problem says that a solid sphere having RT means relative density, a solid sphere having a relative density of X and weighing WGMF when completely immersed in a measuring cylinder changes the reading from VML to Y, V1 ml to Y ml. Then the value of Y is. So definitely Y is kind of unknown. We have to find Y based on the given information. Okay. So first of all, the relative density of the solid sphere is given. So it is given that the RT relative density is given to be X. So from here right away we can say that the density of the solid will be X gram per centimeter cube. If you cannot follow my solution, then I strongly suggest that you please watch the videos where I have discussed the key concepts and formulas on the relevant topic from previous videos. Okay, so we have the density to be X gram per centimeter cube. Okay, now when it is immersed, when the solid is immersed in the measuring cylinder, the reading of the measuring cylinder changes from V1 ml to Y ml. So clearly we can say that the change in reading of the measuring cylinder is nothing but the volume of the solid sphere. So we can say, if I consider V to be the volume of the sphere, solid sphere, V will be equal to Y minus V1 this much ml. Since the reading changes from V1 to Y, definitely Y will be more than V1. So we have this. Okay, we have to find Y. Okay, also the mass, it is said that the weight of the solid sphere is WGMF. So we can clearly say that the mass of the solid sphere will be W gram. Always remember that weight is a force, weight is kind of force, and GMF, WGMF, GMF is a gravitational unit of force or weight. This means WGMF means that it is the gravitational force which is acting on a body of mass W gram. This implies that the mass of the body is W gram. Whereas if it is given that the weight is W kgf, it means that the mass will be equal to W kilogram. So W kgf means a force, the force which acts, the gravitational force which acts on a body of mass W kilogram. Okay, so we have this. Now using the formula that density is equal to mass by volume, we can say that X gram per centimeter cube is equal to mass is W gram divided by V is Y minus V1. Remember, ml is also 1 ml is equal to 1 centimeter cube. So this is Y minus V1 centimeter cube. So we have this centimeter cube. Okay. So this is on the right hand side becomes W by Y minus V1 this much gram per centimeter cube. Equating the so we get X is equal to W by Y minus V1. Okay, so this implies that Y minus, if we simplify from this equation, X equals to W by Y minus V1, we have to find Y. This is clearly a linear equation in Y. So we will get Y minus V1 is equal to W by X. This implies Y is equal to V1 plus W by X. If I simplify this further, this becomes V1 X plus W divided by X. This much Y will be V1 X plus W divided by X. So the correct choice is choice D. D is the correct choice. Okay, let's see the next problem. A cube weighing x kgf has side length twice the radius of a sphere weighing y kgf. So we have a cube. Let's say its mass will be so let's say mc be the mass. I am denoting mc to be the mass of the cube. It is given that the weight of the cube is x kgf, which clearly means that the mass of the cube is x kilogram, whereas the sphere its weight, let's say denote it by ms, its weight is given as y kgf, which means that its the mass of the sphere is y kilogram. Okay. Also it is given that the side length of the cube, side length, this will actually be a cube, side length of the cube, let's say the side length of the cube be a. Now since the weight is given in since we are considering the weight the mass in kilogram, let's consider the side length of the cube to be a meter, and let the radius of the solid sphere be r meter. Okay, so the volume of the sphere becomes 4 by 3 pi r cube, this much meter cube, and the volume of the cube is a cube, meter cube. Okay, now okay, so if the ratio of relative densities of the cube and sphere is m is to n, then which of the following choices is correct? Now please remember one thing, please note one thing, that I might be applying the concept in a little different way. My steps of solving the problem could be different from yours. That doesn't really matter. All that matters is that you need to know the basic fundamental concept clearly and apply them in your way. A particular problem can be solved in multiple ways. Which way you consider in solving the problem does not matter. Just you have to adapt to one way of solving the problem and get and solve it. Okay, so the ratio of the relative densities of the cube and sphere is given to be m is to n. Now then which of the following choices is correct? Okay, so how about we know the mass, we know the volume of both the cube and sphere, so we can clearly find the density of the cube will be mass by volume, which will be equal to x by a cube kilogram per meter cube. Okay, and for the sphere, the density of the sphere will be similarly mass by volume, and this will be equal to 4 by 3 pi r cube divided by y. Sorry, this will be other way around. uh, this will be y by 4 by 3 pi r cube. Okay, which becomes, after simplification, 3y divided 3y divided by 4 pi r cube. Also in the problem it is given that the side length of the cube is twice the radius of the sphere. It is given that A is equal to 2 times the radius of the sphere. So A is equal to twice r. Okay. So the density of the cube becomes x by a cube. A is twice r. This, I am, from now onwards, I am omitting the units. I hope you will understand. So this is equal to x by 8r cube. Now, always remember that the ratio of density of two substances is equal to the ratio of their relative density. So, if you consider two bodies A and B, or substances A and B, so the ratio of the relative density of A, let's say RDA means the relative density of A to the relative density of B will be equal to the density of A divided by the density of the B. This is a concept that you must always remember. Okay, so I can say that it is given that the ratio of the relative densities of cube and sphere is m is to n. So I can say that m by n will be equal to the density of cube divided by the density of sphere. This is equal to x, density of cube was x by 8r cube, and density of the sphere was 3y by 4 pi r cube. This becomes, if you simplify this, this becomes r cube cancels out, and we have in the numerator it will be pi x divided by I think it will be 6y. Okay, so we have this. So we got a relation between x, y, m and n. That is what it is, all the choices has given. Now from this we can say, if I do cross multiplication, I get pi xn is equal to 6y m. Pi xn is equal to 6y m. This should be the relation. Pi xn should be equal to 6y m. So choice C is the correct choice. Okay, let's do the next problem. Question number 3. Okay, a stone weighing W1 kgf when completely immersed in an Eureka can fully filled with a liquid having a relative density as capital P splashes out some liquid from the spout. The splashed out liquid weighs W2 gf. Okay, then the density of the stone in gram per centimeter cube is, we have to find the density of the stone. The mass of the stone is given. Okay. So what is the mass of the stone? To find the density of the stone, we need to know its mass and volume. Mass is already given, as it is given that the weight of the stone is W1 kgf, which clearly means the mass of the stone will be W1 kilogram. Okay. Now the relative density of the liquid, is given to be capital P. In the figure it is wrong. In the figure it is given that RD is equal to X. Actually this will be P. I'm sorry, RD is P. RD of the relative density of the liquid is given as P. Now clearly the water that is splashing up, once the stone is immersed in the Eureka can, the amount of water, the volume of the water that is splashing out from the spout and is collected in the measuring cylinder, its volume will be equal to the volume of the stone. Now the volume of the liquid that is splashing out and collected in the measuring cylinder is not given. Instead, the weight of the liquid collected in the measuring cylinder is given to be W2 kgf. So this implies that the weight of the liquid is the mass of the liquid is W2 kilogram. Okay. Also, the relative density of the for liquid what we have RD, the relative density is given as capital P. We can clearly say, now note that the mass are given in kilogram. So when the mass is given in kilogram, it is better that we use the same unit system, that is SI system, for the density. So we can say that the density of the liquid, I am calling it rho capital L, will be equal to P multiplied by 10 to the power 3 this much kilogram per meter cube. If the relative density is capital P, then its density is P, capital P, multiplied by 10 to the power 3 kilogram per meter cube. And also, if the relative density is capital P, its density in CGS will be capital P gram per centimeter cube. Okay. Now, what is the mass of the liquid that is collected in the measuring cylinder? It is given to be its weight is given to be W2 kgf, which means that its mass will be M2 kilogram. Okay. So now clearly we get the volume of the liquid that is being collected in the measuring cylinder, whose volume is equal to the volume of the stone, which is also equal to the volume of the water that has been splashed out from the spout. So this will be equal to ml divided by rho L, and this becomes M2 divided by P multiplied by 10 to the power 3 this much meter cube. Okay. So we have the volume of the liquid. Fine. What is the question asking? The density of the stone in gram per centimeter cube. Okay. So once we know the volume of the liquid that has been collected in the measuring cylinder, its volume will be equal to the volume of the stone. So we can say the volume of the stone is equal to VL, which is equal to M2 by M2. Sorry, it is not M2, it is W2. Sorry, this is W2. This is W2. This was M and this is W2 is so VL, or the volume of the stone, becomes W2 divided by P multiplied by 10 to the power 3 this much meter cube. So we know the mass of the stone, we know the volume of the stone, we can easily find the density of the stone to be mass divided by volume. This becomes W kilogram divided by W2 divided by P into 10 to the power 3 meter cube. This, after simplification, becomes W1 by W2 multiplied by P multiplied by 10 to the power 3 this much kilogram per meter cube. So this is the density of the stone. It is given, the question is asking the density of the stone in gram per centimeter cube. Oh, we have to find the density in gram per centimeter cube. Okay. So this, if you know the conversion of density from SI to CGS, I've already explained in previous video. This will be equal to W1 by W2 multiplied by P. This much gram per centimeter cube. When we convert 1 kilo, because 1 kilogram per meter cube is equal to 10 to the power minus 3 gram per centimeter cube. So the answer will be choice A. Choice A is the correct answer, correct choice. Okay, let's do the next problem. A sphere of radius r centimeter and density rho 1 gram per centimeter cube has a mass of m1 gram. Okay, another sphere of radius, another sphere of diameter 4r centimeter and density rho 2 gram per centimeter cube has a mass of m2 gram. Find the ratio rho 1 is to rho 2 if m1 is equal to twice m2. Okay. First of all, what is the volume of sphere having radius r centimeter? Let that volume be V1. V1, that is the volume of the sphere having radius r centimeter, will be 4 by 3 pi r cube, this much centimeter cube. And what is the volume of the sphere, the second sphere? The second sphere, for the second sphere, it is given that the diameter is 4r centimeter, which means its radius is 2r centimeter. So the volume will be 4 by 3 pi twice r cube, this much centimeter cube. Okay. For the first sphere, the density is rho 1 gram per centimeter cube, and for the second sphere, the density is rho 2 gram per centimeter cube. Okay, we have to find the ratio rho 1 is to rho 2. Okay, now, so definitely the mass m1 of the first sphere will be equal to V1 rho 1, which is equal to 4 by 3 pi r cube rho 1, this much gram, Okay, and for the mass of the second sphere will be equal to V2 rho 2 gram. This is equal to V2 is 4 by 3 pi 2r cube, twice r cube, this much, and rho 2 gram. Okay. Now, since it is also given that m1 is equal to twice m2, m1 is equal to twice m2. So this implies that m1 is 4 by 3 pi r cube rho 1 gram is equal to 4 by 3 pi twice r cube rho 2 gram. Now from both sides we can cancel out 4 by 3 pi and also the unit gram. So I get from here, I can say that rho 1 by rho 2 will be equal to twice r cube by r cube. Rho 1 by rho 2 will be equal to twice r cube. Okay, so this is equal to 8 r cube by r cube, which is equal to 8 by 1. So this implies rho 1 is to rho 2 is 8 is to 1. So the ratio is 8 is to 1. So the correct choice is B. Okay, let's see the last problem. Question number 5. Okay, a measuring cylinder filled with water has an initial reading of V1 ml. A body A of density rho A gram per centimeter cube is gently immersed in the cylinder and the reading becomes V2 ml. Okay. Okay, another body B of density rho B gram per centimeter cube is gently immersed in the cylinder and the reading becomes V3 ml. Okay, if both the body A and B weigh equal, then the ratio rho A is to rho B is. Okay, so the first figure, we can see three figure. The first figure is the situation where the measuring cylinder is initially filled with water, is having a reading of V1 ml, which means that the volume of the water inside the cylinder is V1 ml. Fine. Now, after the body A was immersed in the measuring cylinder, the reading of the measuring cylinder becomes V2 ml. So clearly, we can say from the concept of a displaced liquid, we can say that volume of the body A is nothing but V2 minus V1 ml. Initially, when there was no body, only the liquid, only water, the reading was V1 ml. Now, when the body was immersed in the water, definitely the level of the water will rise by a volume which is equal to the volume of the body A, and the reading has become V2. So definitely the increase in volume is V2 minus VML, and this increase in volume is equal to the volume of the body A. So VA, that is, if you denote VA to be the volume of the body A, is equal to V2 minus V1 ml. Now again a body B was immersed and the reading was V3 ml. So definitely we can say the volume of the body B is nothing but V3 minus V2 this much ml. This much ml. Okay. So we got the volume of the body A and the volume of the body B. Now the densities are given. The densities are for the body A. For the body A, the density is given to be rho A gram per centimeter cube, and for body B, the density is given to be rho B gram per centimeter cube. Okay. Now, if both the body A and B weigh equal, then the ratio rho A is to rho B is. So the mass of the body A becomes VA multiplied by rho A, which is equal to V2 minus V1 multiplied by rho A. This much gram. Remember, ml is 1 ml is 1 centimeter cube. So you can say that VA is V2 minus V1 centimeter cube. Also, V3 minus V2 ml is equal to V3 minus V2 centimeter cube. Okay, so we have mass of the body A is V2 minus V1 multiplied by rho A, this much gram. Similarly, mass of the body B is VB multiplied by rho B, which will be equal to V3 minus V2 multiplied by rho B multiplied by rho B, this much gram. It is given that both the body A and B weight equal. Now, if the weight of two bodies are equal, definitely their masses are equal. So we can say that MA is equal to MB. MA is equal to MB. This implies that V2 minus V1 multiplied by rho A is equal to V3 minus V2 multiplied by rho B. So from here clearly we can get the ratio of rho A and rho B. Rho A and rho B will be V3 minus V2 divided by V2 minus V1. So this implies okay. So the correct choice rho A by rho B will be equal to V3 minus V2 divided by V2 minus V1. So the correct choice is V2 minus V1. The answer is not matching with any of the choices. Let me check if I did it correctly or not. If both the body A and B were equal, then the ratio rho A is to rho B is. Okay. So initially the reading was V1 ml. After the body A was immersed, the reading becomes V2 ml. So clearly the volume of A will be V2 minus V1, V2 minus V1 ml. Okay. And the again when the body B was immersed, the reading became V3 ml, which means that the volume of the body B will be V3 minus V2. Will be V3 minus V2. Okay. So definitely mass of the body A will be V2 minus V1 multiplied by rho A, and mass of the body B will be equal to V3 minus V2 multiplied by rho B. And since both the weight are equal, MA is equal to MB, we will have V2 minus V1 multiplied by rho A is equal to V3 minus V2 multiplied by rho B. So this means rho A by rho B should be equal to V3 minus V2 divided by V2 minus V1. So this is the correct ratio. I can see that I have incorrectly given the choices. The correct answer is not given in the choices. So I'm sorry, this is my mistake. Anyway, so this is the correct ratio. So this brings to an end in solving 5 multiple choice problems. This is set 1 on the topic of determination of density of solids. In the next, I am not sure whether I will be able to frame more questions or more problems for set 2 on this topic. If I can, I will, and will upload the video tomorrow. If not, then tomorrow I will start discussing the next topic, which is determination of density and relative density of liquids. So please stay tuned for the future videos. If once again, if this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.